Okay, let's take a look at graphing single variable inequalities on the coordinate plane. In the past, when we've had a single variable and graphed the solution set to an inequality, we've always done it on a number line. So for example, in the past, when we've graphed x is greater than -2, we've drawn a number line, come across to -2, put our open circle with an arrow to all the values that have a value greater than -2. We can do a similar thing on the coordinate plane even though we have a single variable. So in this case, we're going to actually graph the line x equals -2. And remember, the line x equals -2 is a vertical line at -2 on the x-axis. And remember, it's vertical because every coordinate along this vertical line has an x-coordinate that is -2. Now, since this is a strictly greater than symbol, we're going to come to x equals -2 and we're going to draw a dashed line because it's not going to include the value -2. That line goes on forever, so we're going to make sure we put arrows on the end of it. And all the coordinates that have x values that are greater than -2 exist to the right of this dashed line. And what we're saying is that every coordinate to the right of this has an x-coordinate that is bigger than -2. So if we just picked out a random point, so here's a coordinate over here, and if I write down the coordinates are 1, 2, 3, 1, 2, 3. I'm saying that the x-coordinate has a value that's bigger than -2. And so every point along here, anywhere I pick over here, will have an x-coordinate that's bigger than -2. So let's illustrate that one more time. Let's look at one that's not a vertical line, but let's look at one that's a horizontal line. So we're going to look at the single variable inequality, y is less than or equal to 3. And we're going to graph the line y equals 3. And remember, y equals 3 is a horizontal line crossing the y-axis at 3, because every point along this horizontal line has a y-coordinate that is 3. Now, because I had a greater than or equal to, my boundary line is going to be solid. So I'm going to graph a solid line. I'm going to put my arrows on the end because that line extends both directions forever. And I want all the values, all the y values that are less than that. So I'm going to shade beneath. And again, anywhere I pick underneath this line, so if I pick this coordinate, the coordinate there is 2, 1. And the y value of that coordinate is smaller, it's going to be smaller than 3. So again, even though we have single variable inequalities, we can still graph them on a coordinate plane. They will end up either being vertical lines if they're an x variable, or a horizontal line if we're working with the y variable.